the extended power rule and which is really the chain rule, and the quotient rule. So if we go through and first look at the quotient rule, let's say I have some function f of x. I have the numerator and the denominator. So therefore, the quotient rule says I take the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator all over the denominator squared. All right, then I'm going to go through and do the same thing for the denominator, but with the denominator, this is going to be an example of where I need to use the chain rule or the extended power rule. So for the extended power rule, the first thing you do is I'm bringing that 4 out front, so that stays as a 4. Now everything on the inside stays the same, and that's really important. And then the exponent is 4 minus 1 or 3. Now I take the derivative of the inside, and the derivative of the inside in this case is just negative 4. All right, so now I can go through and do all of this. So the derivative of the numerator is 9x squared times the original denominator, which is 3 minus 4x to the 4th. Now I subtract out the original numerator, 3x to the 3rd, times the derivative of the denominator, and I'm going to go ahead and just combine those. That's going to be negative 16 times 3 minus 4x to the 3rd power. And this is all over the denominator squared. So with this, just be very mindful about how you're combining these exponents, because that's 3 minus 4x raised to the 4th quantity squared. So now to simplify all of this, make this a little bit smaller so I can fit it all on the screen at the end for you guys. So now I simplify this out. I'm left with 9x squared times 3 minus 4x to the 4th power. Those two negatives are going to go ahead and become a positive. 3 times 16 gives me 48. X to the 3rd. 3 minus 4x to the 3rd. And in the denominator, that gives me 3 minus 4x to the 8th power. Now, the same thing that I did in the other previous video, I'm going to take my GCF. So my GCF between 9 and 48. So my GCF between 9 and 48 will be a 3. X squared, because that's going to be the smaller of those two. And then 3 minus 4x will be to the 3rd power, will be my GCF. And that's because I'm looking at this exponent and this exponent, and I take the smaller of the two. All right, so now what's next is I pull that out, and I have my GCF is 3x squared times 3 minus 4x to the 3rd power. On the inside, that leaves me with 3 times 1 more 3 minus 4x plus, and then 48 divided by 3 is 16. I'm left with 1 more x. That would bring me to x squared, but nothing, no more of the 3 minus 4x's. All over my denominator. I simplify what I have on the inside. And that leaves me with 9 minus 12x plus 16x. Denominator, I'm not going to do anything with that. Actually, let's go ahead and do that now. So with the denominator here, everything inside here and here are the same. So I can go ahead and subtract those exponents, and that will cancel out, and that's going to become 8 minus 3. And my final answer will be 3x squared times, I'm going to put this in descending order, 16 minus 12x gives me 4x plus 9, all over 3 minus 4x raised to the 5th power.